Hi, my name is Paul Krieger, Professor of Biology at Grand Rapids Community College, and I'd like to do a presentation today to share with you 10 tips for studying the skeletal system. Here's the outline. Point 1, learn the bone markings. Point number 2, be sure to set up a study schedule. Number 3, get very organized. Number 4, use analogies and mnemonics as appropriate. Number 5, don't blindly memorize terms. Number 6 is visualize how bones function. Number 7, examine patterns. Number 8, study with a buddy. Number 9 is make your own flashcards. And number 10 is, and most importantly, practice, practice, practice. So let's elaborate on each of these points a little bit. First of all, learn the bone markings. What are we really referring to? If you actually look at any textbook, they're going to have a set of terms that apply to all parts of the skeletal system. And these are found again in pretty much any textbook. You'll see a table, and they'll typically be called bone markings. And let me give an example of one of the common terms that you would see. One of them is called a foramen. And a foramen simply refers to a hole through which a blood vessel or a nerve passes. In this slide, what we're seeing is a picture of the mandible, or your lower jaw, and that's just like what we see here. And if we look down here, we notice that there's a hole right there in the mandible, and that's referred to as our mental foramen. So the term in this case is just showing me where the hole is located. Another term is condyle, very, very common term. An example of this would be like what we see at the end of a long bone, such as a femur. This is the longest long bone in your body. And if we look at the end of it, just like we can see also in the slide, we have two curved surfaces like this. When I have two curved surfaces that form a joint or an articulation, they're referred to as a condyle. So, foramen, condyle, two very, very common terms. They come up in many parts of the skeletal system, not just with the bones I just showed you here, but many others. And if you know those first, it'll help you understand all the different parts of the skeletal system. So very important to do this as one of the first methods of attack in your study plan. Number 2, set up a study schedule. Chunking, what is it? When you first come upon the skeletal system, you're overwhelmed with the amount of information that you have. It's just too much. So like any huge task, what you need to do is break it up into tiny pieces, called chunking. So we take our huge task and we break it up into little tiny pieces, and it makes everything a lot easier. So what you need to do is study a little bit every day, each and every day. The long bones tend to be the easiest thing to do. So for example, I mentioned a femur earlier, the longest long bone. This tends to have some of the least amount of structures on it that you need to know. They're very minimal compared to other things. So because these are easier long bones, you may want to start there first. That gives you some momentum and carries you over to learning the more complicated things. What's the most difficult thing? The most difficult thing you're going to have to conquer is the skull. The skull has numerous bones and sutures and different processes and projections on it, and it takes a long time to learn the skull. So since this is the most difficult, you may want to wait a little bit until you start to attack that one. So if you like to build a little momentum in your studying, you'd want to go for long bones first and then gradually work your way up to the skull. Third point, get organized. First of all, you want to put all your materials in a 3-ring binder like is shown in this slide. So you may have printouts that have your learning objectives on them, etc. It's good to have them all organized in a nice 3-ring binder. You may want to have like a little Ziploc pouch in which you could put some colored pencils, as is shown in this slide, and those are very helpful for active learning activities such as color coding the bones and using some of your illustrations as a coloring book. In addition to that, getting organized means highlighting the structures that you need to know. Since you're never going to be required to know everything in the skeletal system, you're going to need to know specific learning objectives. You need to highlight the structures, for example, on the skull, that you need to know before you come to your lab. And that way you're really well prepared for focusing on just what you need to know and not worrying about anything else. So you highlight those in your primary reference, which is your textbook or your lab manual or your photographic atlas, whatever you're using as your primary reference for your lab. In addition, you want to group similar things together. An example of this would be if I was working on the skull here, one of the first things, probably one of the easiest things to do, is to learn the bone names first. So I would learn the frontal bone, the two parietal bones, the occipital bone in the back, and be organized that way. Learn some of the bones that make up the cranium. Another thing I could do is then approach it to learn some of the sutures. These are points where one bone is joined to another, and then move onward. So learning the bones as a group, learning the sutures as a group, that's an organized learning method and a good way to go. Finally, another example of learning in an organized manner would be like what we see in this next slide. If we look at this, this is an example of the long bone that we showed earlier, the femur, longest long bone in the body. A good tip for this one, as is shown in the slide, is it says, let one end of the bone tell you something about the other end. So, for example, if I look at this, notice that this portion right over here is referred to as the head. So I'll hold up the same example right over here. So as I look at this structure, this is the head of the femur, and this is going to form a ball and socket joint in the hip. But actually, if I look at the head of this femur, it tells me the name of this structure way down here at the other end. So as I look at this, notice that the name for this is the medial condyle. And that matches this because the head always points medially, meaning toward the midline of the body. So for example, if I were to put this in me, the femur would fit in like this. Notice the head is pointing medially toward the center of the body, and that's a directional term. So we say the head points medially. When I look down here, the name of this curved surface, my condyle, is also the medial condyle. So looking here at this end tells me the name of the similar structure located at this end, similar directional term actually. Fourth point is to use analogies and mnemonics as appropriate. And what I've done is taken some examples from my book called A Visual Analogy Guide to Human Anatomy, and I've shown you some of the same ones that I'd be demonstrating in a regular lab. So let's take a look at some of these analogies that we would typically see. The first one that I have over here is I have an example of a humerus. So this humerus would be located in this region of the body, in the arm, such as this. And imagine that I were to cut that straight down the middle and make a cut like that. If I expose it that way, then what I'm able to do is see some of the internal structures. And the point here is that I could actually see two different types of bone. In the wall of it, referred to the wall of the shaft called the wall of the diaphysis, I see compact bone that's very dense. If I look at the end of the bone called the epiphysis, then I see a different type of bone called spongy bone. And so this one's very, very porous, like a sponge, as opposed to the bone that you find in the wall of the diaphysis, which is much more compact, much more dense. And so that's a little analogy to remember your spongy bone. If I look at the compact bone that we saw over here inside the wall, and I were to zoom in on it and look at it in a microscopic view, I would see a normal repeating structure, which is referred to as an osteon. So imagine now this model is showing me a microscopic view of a wedge of that compact bone that I took from the diaphysis. This is the outer portion here. This is the inner portion here. If you look at this, you notice there's a big tower here that's been pulled out and a tower here that's been pulled out. There's a repeating unit referred to as an osteon. If you're to look closely at the surface of this, it looks very much like in the cross-section of a tree stump or the cross-section through a tree. So if I were to compare this to what I see here with these little tree cookies, I can see that we have rings and rings upon each other, concentric rings in each one of these osteons, and they look like the annual growth rings inside of a tree. So the term for each one of those rings in an osteon is one lamella, and they very much look like the growth rings of a tree. So it's a good way to visualize the osteon. Now if I go over here and I take a look at the skull, and I want to remember one of the sutures of the skull. This suture that goes straight across in this direction is referred to as the coronal suture. And coronal means crown. So just like I might have a beauty queen that wears a tiara, such as this, I'll place a little band in the direction that would go on the head, such as this. And if I look at that, notice that the band goes in the same direction as the suture. So that's a good way to remember it. Coronal, crown, goes in the same direction as this suture, so that one's located right over here. Another example, if I were to look at the posterior aspect of the skull, I would basically see something that looks like this. I have kind of what looks like a modified peace sign. I basically have a suture going down here called your sagittal suture that comes along here like this to one called the lambdoid suture. So you have kind of what looks like a modified peace sign, such as that. And if you were to actually put the first letter of each of the bones on top of it, you can kind of visualize those bones. So here what I have is parietal bone. I have two of those, so P and P for parietal bone and parietal bone. And then down here at the bottom, I have my occipital bone at the very most posterior portion of the skull. So if you kind of superimpose or visualize the letters P, P, O, and you put them in a modified peace sign such as this, it helps you remember those bones. Now let's go over and take a look at something else. Let's go over here and take a look at a bone that's quite difficult to visualize in the skull. This bone that I have in my hand, a plastic model of it, is referred to as the sphenoid bone. And the sphenoid bone is very difficult to visualize because it's embedded inside the skull. So if I were to take off the skull cap and I were to look inside the skull, I can kind of see the outline of this bone. And let me kind of highlight it for you with a laser pointer. If I look over here, what I can see is the outline like this. This is the outline of the sphenoid bone. And so I'm seeing where it's embedded inside the skull here. So it would fit inside of the skull like this. And if I want to just see the bone all by itself, a good thing to compare it to is a bat. And so as I look at this one, I would see, okay, here's my sphenoid bone, here's a bat. And it's very helpful for remembering the names of some of the parts, because just like the bat has a large wing, what do we call this similar portion of the sphenoid bone? The greater wing. If we were to imagine that the bat had very long ears, these portions right over here are referred to as the lesser wing. So the lesser wing are like the long ears of the bat, and the larger portion here, the greater wing, is like the actual wing of the bat. And the body would be like this little saddle-like structure we have right over here, and that saddle-like structure is referred to as the sella turcica. That's there for the pituitary gland to rest on. Now if we look over here, we just said that it looks like a saddle-like structure. So here's a picture of our saddle, like a saddle on a horse. And that sella turcica, which again is right here, that our pituitary gland rests on, is actually shown here, and we can kind of visualize that like the saddle of a horse. Now, keeping that in mind, one of the things that we want to do is we want to visualize this little guy. This little guy right over here, we're going to call Ross the cowboy. And you can see Ross the cowboy is sitting on the saddle of the horse or sitting on the sella turcica. What exactly is the purpose of this? The purpose of this is to learn 5 holes. Remember at the beginning we said there's a term called a foramen. The plural for that is foramina. One foramen, many foramina. The foramen is a hole, we said, through which a blood vessel or a nerve passes. For the sphenoid bone, it's common in learning objectives that you need to learn many of the foramina. I'm going to go through 5 of these foramina, show them to you, using Ross the cowboy as our analogy. Okay? So as we look at this, we're visualizing Ross seated on the saddle. And as we look at this, we say, oh, okay, his legs are going down through a hole here. And actually, if we flip the skull, we can see where his legs are going through on the other side by those indicated by the blue pipe cleaners that you see there. We can also see where his arms are going through. Notice his arms are going through a portion that goes into the back of the orbit of the eye. Okay? So those are 2 important foramina. What's the name of those? His legs go through a foramen called foramen lacerum, so you remember that by the L and L alliteration, legs lacerum. His arms are going through one called the optic canal or optic foramen, and that you can easily visualize if you look here. Imagine the eyeballs inside of that socket. What's going to need to pass through that hole? The optic nerve of the eye needs to go to the brain, and it has to pass through the skull to do it. So just like a cowboy would be grabbing the reins of a horse, Ross the cowboy is grabbing the optic nerve, which is going to go through that hole to allow the optic nerve to go to the brain. So why is Ross's name Ross? Why is he Ross the cowboy? His name comes from 3 holes inside of the sphenoid bone, and let's examine those. If we look right over here and we start toward this in the medial direction, we have this one, and this one, R-O-S. The first one's called rotundum. The second one's ovale, oval shape. The last one's spinosum. That's where Ross gets his name from. Now it's actually symmetrical on the other side. So if I go to the other side, I'm going to see the same pattern, R-O-S, rotundum, ovale, spinosum. So with this little visualization technique, we've learned 5 different sphenoidal foramina, or holes in the sphenoid bone. And that helps us learn those. So instead of just seeing a whole bunch of arbitrary holes, we have them organized in a systematic way. Now let's go over to the vertebral column. And if we look at this vertebral column, it shows us all the vertebrae linked together. Now, one of the things we need to know is the different types of vertebrae. And if you were to look at the demarcation indicated by this blue pipe cleaner, then this shows the vertebrae that are in your neck, the cervical vertebrae. How many of them are those? There's 7 cervical vertebrae total. And then if I look at those in this region in the center, these articulate with the ribs, and there are 12 of those. Those are your thoracic vertebrae. And then if you look toward the bottom, as the number indicates here, we have 5 lumbar vertebrae. So how do you remember these? You remember it with meal times. If you start early in the morning, you have an early breakfast at 7 a.m. You have lunch at noon, 12 noon, and then you get off work and have an early dinner at 5 o'clock. So meal times will help you remember the total number of each type of vertebrae. So 7 for cervical, 12 for thoracic, and 5 for lumbar. Now, if we look toward the bottom of the vertebral column, we have a bone called the sacrum, and that's the one I'm holding in my hand right here. On the end of the sacrum, there's a separate group of bones which are indicated as everything below this pipe cleaner. So I usually see a group of 3 to 5 bones, and those bones are actually look very similar to what we'd see for a rattlesnake tail. So that's referred to as your coccyx. So your coccyx, that group of 3 to 5 bones, commonly called your tailbone, looks very much like a rattlesnake tail. Now, if we go over here and we look at this, this is showing you some vertebrae. So we're still working with our vertebral column. And if I look at this one, there are two bones at the very, very top of the vertebral column, and they have a special name. The very first one that hooks up with the skull or articulates with the skull is called the atlas. Cervical vertebra number 2 is called the axis. So these two are actually going to hook up with each other so that you can pivot and turn your neck from side to side. As you look at these, I just want to show you a visualization technique for each one of these vertebra. If you look at this one, this is the atlas, and if you notice, atlas looks a little bit like our Atlas the turtle here. And if I look at this, it kind of looks like, oh, a turtle head with the turtle wearing glasses. And if you look at that, this portion of what will be the lens of the eyeglasses is called the superior articulating process. And then this part that I have over to the sides that my fingers are touching would be called the transverse process. That would be like the arm of the eyeglasses. So again, that's called the atlas, a special bone that holds up, that's right at the base of the skull. If you look over here, this is actually the axis, and the axis kind of looks like a football player. So here we have our football player, and we're comparing it to this, and there's our axis. And we say, okay, the head of the football player right here kind of looks like this structure, and that's referred to as the odontoid process or the dens. Either term is correct. If I look at the shoulder pads of the football player, these kind of look like shoulder pads. That's referred to as the superior articulating process. And then if I look over here, the portion where he's holding the football is this portion on the end, which is referred to as your spinous process. So this helps you visualize this very special cervical vertebra. Now, if I move on over here, I have a couple other little techniques. Let's finish up vertebra and move on to something else. If I look at this, this is one of your thoracic vertebra. And a thoracic vertebra looks very much like the head of a giraffe. So if I were to show these two together, you can see that they look very, very similar. So we're looking at the posterior portion, or the back, of this vertebra. And as I look at it, it looks very much like the head of a giraffe. So let me just go through the parts of what you can see and how they relate to a giraffe head. The part that looks like the snout of the giraffe is my spinous process. The part that would be the ears of the giraffe are actually the transverse processes. And the part that looks like the horn of the giraffe are actually the superior articulating processes. So by superimposing this image on that bone, you can learn those parts quite easily. If we go over here, this is a lumbar vertebra, and a lumbar vertebra looks somewhat like the head of a moose from the posterior view. So similarly, we can superimpose the image of the moose head on the back of this vertebra and learn some of the parts. So let's do that. The snout of the moose would be what we refer to as the spinous process. The part that dangles down, called the bell of the moose, would be your inferior articulating process. What would make up like the part of the antlers of the moose would be the superior articulating processes. And the other part of the antler that sticks out at the sides would be my transverse processes. So those help me learn a few of those parts of the vertebra. Now, another thing I can do is I want to be able to distinguish what's the difference between a lumbar vertebra and a thoracic vertebra. You can see they look quite different. There's a very large section called the body on lumbar vertebra, but a smaller one on a thoracic vertebra. But here's another little trick, a visualization technique. If I were to compare this view of the vertebra, which is looking down on top of it, called the superior view, it looks kind of like a goose with its wings stretched out in flight. The neck of the goose is actually this portion, the spinous process. And notice the angle between the head over here and the outstretched wing. It kind of makes a 90-degree angle, and that 90-degree angle would be nice for fitting in the letter L, which is also telling me that it's lumbar, And that's what I can do on my vertebra. I can say, oh, that's about a 90-degree angle, so I remember L for lumbar. So I superimpose the letter to remember it's a lumbar vertebra. Now, if I move on over here, I can look at the sternum, your breastbone or the sternum. And that would fit in me just like this. And it has three main portions to it. And to visualize those three main portions, I can use a sword as my analogy for that one. The handle of the sword would be this portion at the top, and we call that the manubrium. The middle portion, which would be like the blade of the sword, is what we call the body. And the tip of the sword down at the bottom would be like the very tip of my sternum, and that's called the xiphoid process. So that helps us learn that one. Now we can move over here. So we just finished doing the sternum and had an analogy for that. Now we want to move over to the arm and do a few analogies for bones in the arm. So as we look at this, here's our arm, and if we look at our upper limb or our arm, we have a humerus on the top. That connects to a radius and an ulna below it, and that connects into the hand. So let's look at each of those bones. The first one is the humerus, which we can see here. And this humerus would fit in my skeleton just like this. And if I want to learn the portions at the end of this humerus, called the distal end of the humerus, what we can do is we can visualize it simply by taking your own hand and putting your thumb out like that. And if you look, you notice that there's a little bump over here that looks kind of like a hitchhiker's thumb. So imagine you're making a gesture like a hitchhiker would. The thumb is referred to as the medial epicondyle. Now notice there's a bump here and there's another bump here. Well, these are actually both condyles that have special names. These are like my curved fingers that you see here and here. So this first one is referred to as the trochlea, and the second one is referred to as the capitulum. So if you visualize this hitchhiker's thumb and a clenched fist like this, it helps you understand those portions of the bone at the distal end of the humerus. Now let's move on to the radius and the ulna. The radius and the ulna look like this. This one is the radius. This one is the ulna. So our first challenge is, how do we tell them apart? The ulna is quite easy to distinguish from the radius because if you look at this, it looks very much like a wrench. So here's my wrench, here's my ulna, and because of the type of connection it makes at the joint in your elbow, this looks very much like a wrench. Now, if I were to look over here, I also have another way of learning that one, and that's to take this letter U and to superimpose it in this section here. It's basically telling me I'm the ulna, so you can remember it that way as well. When I look at the radius, one of the things that stands out about the radius is that the top of it is very rounded. So you can remember the alliteration, rounded radius, at its head, at the top, just this portion called the head. It looks very much like a hockey puck. So here's my hockey puck, and the head of that radius looks a lot like that, so that's a good way to remember it. Now, if I were to look at the joint that's formed at your elbow, I can make an analogy to that as well. Here's my joint at the elbow, right over here. And notice the head of the radius has to articulate or hook up with this structure that we looked at earlier called the capitulum. And also notice that this portion of the ulna hooks up here with this part called the trochlea. So to understand how those joints fit together, we can look at it like this. The rounded portion of the humerus, which is that portion called the capitulum, is actually going to fit on the head of the radius like that, like this ball on top of the head. So that kind of helps you understand how the joint works, how the joint fits together. And similarly, if I look over here, if I were to think of this wrench as hooking around this cylinder, that's very much like what happens in the joint with our elbow. And the name of our elbow is our olecranon process, is the name of this part of the ulna. So if I were to compare that to this, I could pull this up and I could say, oh, this portion right here is my olecranon process, which is like that portion of the wrench, and we can see how it forms that joint with the humerus, okay? So now we'll move on to going down toward the lower limb, or the leg. And in the lower limb, between the knee and the ankle, you have these two bones. One of them is called the tibia, and the other is called the fibula. And one of the things you have to do is distinguish these two bones apart. Your tibia is commonly referred to as your shin bone. And so as you look at these two, notice that the tibia is much bigger, thicker, has much more dense layers of bone than does the fibula. So how do you remember those together? Well, we use an alliteration for this. And the alliteration for this is tough tibia, T and T, and the alliteration for the fibula is fragile fibula, F and F. So tough tibia, T and T, fragile fibula helps you remember how those two are different. Now let's move over to the pelvis. And if I look at the pelvis, one of the things that I see is a big, huge depression. And that depression has a tongue twister of a name called the acetabulum. And this is where the head of the femur is going to hook up to form the hip joint. And the term acetabulum literally means cup of vinegar. So if you visualize a cup just like this, physically looks like a little cup, you can kind of remember that one, and it helps you remember the origin of the term. So acetabulum right here, cup of vinegar, just like this. One other thing for the pelvis that we can look at is we'll look over to the anterior part of the pelvis, or the front of the pelvis, and we see two bones that come together, and those two bones that come together are called pubis bones. And those bones actually look somewhat like a mask, like what we could see here. So as I look at those, notice the eye hole for the mask is very much like the big holes that I see there at the front. And if you remember earlier, we said, what was the term for a hole? A foramen. So there's a big hole here and a big hole here. So this foramen and this foramen, they're named obturator foramen for each of those. So this helps you visualize the two pubis bones and each obturator foramen within that. Okay, so that really finishes up some of our analogies. Now what we'd like to do is move on to some other points about some other study tips. So we just finished point number 4, using analogies in mnemonics. Let's move on to some others. Number 5 says, don't blindly memorize terms. Many times what students do is they just look at all of the things they have to learn as just a big sea of disconnected information. That's exactly what you don't want to do. Instead, what you want to do is understand the meanings of the terms. As you can see in the slide, it says terms tell you really important information if you know what they're telling you. So, for example, let's look at two terms that you would come across. Mental foramen, we talked about a foramen earlier, and olecranon process. We briefly mentioned that one earlier as well. If you look in this image on the slide, it shows a mandible again, just like what we had earlier. And so, again, we had this when we talked about bone markings. We said, oh, mental foramen, we talked about it earlier. We pointed to this little hole that we have inside of the mandible. Well, what does the term mental mean? Chin. What's foramen? Hole. So what's the entire term telling you? Literally, it means the hole in the chin. That's very useful information, but that assumes that you know what mental means and what foramen means, okay? Now, if we move to the next term, it says olecranon process. What's the olecranon process? Well, you can see in the image on the screen, it's actually this whole process that we see right over here that makes up your elbow. It's on the ulna. So that's what we're seeing in the image on the screen as well. If we look over here to the arm where we can see everything hooked together, you can very easily see the olecranon process right here, your elbow. So it's the olecranon process of the ulna. What does the term olecranon mean? Elbow. So if you understand that, you understand the terminology, and that's very, very helpful. Also, a final point about naming. you have to work with the naming system that's already used in the skeletal system. For example, it says on the slide, structures are often named after what they connect to. Let me give you an example. If you look in this slide, we have a color-coded example of a skull. And if you look closely on the skull there, you're going to see a pink bone that has a T superimposed on it, which is short for your temporal bone. You also will see an orange bone that has a Z superimposed on it, which is short for your zygomatic bone or your cheekbone. Now, if you look closely, we want to name parts of each of those bones. So if we look inside the slide, notice that there's one portion that's sticking out of the temporal bone that looks, has that same pinkish color, looks pink, like a long arch. What do we call that? Well, students' first instinct is to call this, oh, that's a process because it's sticking out a bone, yes, and they want to call it the temporal process of the temporal bone. But that's not the way the system works. What is it called instead? Take a look at the screen. We call it the zygomatic process of the temporal bone. Why? Look at what it's connecting to. It's connecting to the orange bone. And what's the orange bone's name? Zygomatic. See the system? Zygomatic process of the temporal bone. Now, similarly, let's apply the same rule to the other portion of the zygomatic bone. See that little teeny part that makes up a portion of that arch that's orange that we just highlighted in the bracket on the slide? What do they call that? With the same system, they're going to call it temporal process of the zygomatic bone. They're naming it after what it connects to, not what it comes from. So now the question is going to be, well, is this the only place they use that system, just in the skull? And the answer is no. Where else do they use it? Let's give another example. If I go over to look at this image that you see on the screen, this is the radius and the ulna. We saw that earlier, right? When we looked at the arm, we said, oh, here's the radius and the ulna, and they connect to the humerus. If I were to look together, there's a little place where they join that shows up as a little groove or a little notch. What do they name that? It's not fully visible in what you see in the screen, but the arrow's pointing to it. So what's the system that they're going to use for naming? They're going to call it the radial notch of the ulna. So there's a little groove on the ulna for the head of the radius, and the naming system is the same as what we described before. Now if we go at the other end, we also are going to see another image. And guess what? The ulna and radius have to hook together down there as well. Look at where the arrow's pointing for that one. This one says ulnar notch of the radius. So in other words, the groove on this one is actually on the radius, but it's for the ulna or hooks up with the ulna, so that's why they do the naming system like that. So bottom line is, the naming system works to name a structure after what it connects to, and that's common throughout the skeletal system. So don't fight that system, work with it, and naming's a lot easier. Number 6, new point, visualize how bones function. So for example, if you look and see this image, it's showing us an image of the knee joint. And as I look at that image of the knee joint, I can actually say to myself, here's a knee joint, and here is the femur connected to both the tibia and the fibula. And so if I were in lab, you may have a whole articulated lower limb like this, or the bones might all be in individual pieces. If they're in individual pieces, what you do is you put them together and you look at how they connect together. And by looking at how they connect together, it really helps you understand not only how things are named, but also how they function. And that's a really helpful learning tool. It's a good active learning tool to learn the skeletal system. So you want to visualize how things function. So for example, you can connect bones that go together, and you can look at as if it were pieces of a puzzle. See how things articulate for a knee joint. See how they hook up for an elbow. See how they hook up for a shoulder joint, a hip joint, any of those. So that's point number 6. Moving on to point number 7, it says examine patterns. And for this, what we're going to do is compare a few different things. Our first comparison will be the upper limb and the lower limb. Second comparison that we'll look at is the femur and the humerus. Third comparison is feet and hands. And so let's do each one of those. In the image on the screen, we're going to look at the upper limb first. What's the big picture pattern? The big picture pattern is just what we saw here. We have one bone that connects to two bones that then connect to many bones in the hand. So as you can see in the image on the screen, the idea here is one bone, namely the humerus, connects to two bones, namely the radius and the ulna, and those connect to many bones in the hand. Well, we'd see the same thing if we were looking at the lower limb, because it's the same exact pattern. So as we look at this, what do we see? Well, let's take that out as an example. We have the femur here, which is one single bone, and that hooks up to two other bones, namely the tibia and the fibula, and that hooks up to many bones in the foot. So one bone connecting to two. Even more importantly, what you'll also see is both the humerus and the femur form ball and socket joints. The humerus is going to form a ball and socket joint in your shoulder. The femur is going to form a ball and socket joint in your hip. So knowing the pattern helps you recognize how some similar structures are going to appear. Now, if we look at the screen, what we're also going to do is we're going to compare this. We're going to say, okay, let's look at a humerus and a femur, because those two bones have a lot in common. We just said that they both form ball and socket joints, so not surprisingly, a lot of the terminology is the same. Look at what the white lines are pointing to on the screen. The white lines are pointing to what? Structures called condyles. What are condyles? Condyles were a curved surface that form a joint. Like if we were looking at the end of this femur, for example, this would be a condyle and this would be a condyle. This is going to form part of the knee joint. Well, I have similar names because I have similar structures with similar functions. So condyles for those. If I look toward the other end of the bone or other epiphysis, I'm going to see terms that come up: greater something and lesser something. So as I look at this one, what I actually see is a pair of terms, greater and lesser. Now, what do greater and lesser actually refer to? They refer to the size. So larger and smaller is what it's really saying. In the humerus, that's pointing to a structure called the tubercle. So we have the greater and lesser tubercle. Inside the femur, it's referred to as the greater and lesser trochanter. So we see a set of paired terms that are the same in both bones. And then finally, I also have a head on each one of those bones that's going to form a ball and socket joint with its appropriate structure. So again, the head of the humerus goes into your shoulder, the head of the femur goes into your hip. Okay? So you're going to see a lot of similar names for those two bones because they're structurally similar, forming similar joints. Now let's take a look at the hand and the foot. If we look at the image on the screen, it's color-coded. And the color coding that we have shows you white for bones in your ankle and your wrist. And then it shows kind of a pink color for bones in the palm of your hand or bones for the middle of your foot. And then for the fingers and toes, it shows those as yellow. So look at the overall pattern. In your wrist and your foot, what do they call the terms? What's the name of those? They're carpals in the hand and tarsals in the foot. Very similar name, carpals, tarsals. Notice there's 8 carpals in the hand, 7 tarsals in the foot for the ankle. Then if I go down to the pink color coded, what's the code name? Metacarpals for the hand, and it's metatarsals for the foot. Then when I go to the phalanges, I have phalanges for both fingers and toes. Same name, so similar structure. Notice for each one of the phalanges, we got 3 bones. So you see 3 individual bones for each finger or each toe. What's the only one that doesn't have it? In the thumb, I only have 2, and in the great toe, I only have 2. Similar pattern. So thumb and great toe have 2 phalanges. The rest of the digits have 3 phalanges. Number 9, new point, make your own flashcards. What you want to do is be engaged in a very active learning process. So it says the act of making them is actually an active learning process, as opposed to buying a set from a publisher. So I encourage students to actually make their own flashcards. It's really a better way to learn. So it mentions that why is it better than the publisher set? Well, first and foremost, it's going to be customized to your own learning objectives. If you buy a set at the store, it's going to have probably a lot of structures that you don't necessarily need to know. And this basically will be customized exactly to what you need to learn for your learning objectives for your class. And in the last point, it also mentions that it's a lot less expensive than buying a set from a publisher. So you can save money, it's customized learning, and it's also an active learning process just by making them. So how would you go about doing that? If we look in the next slide, what we'll see is an example, sample. I have a picture in the slide that shows the front of a typical card, and we have the term femur on the front. So let's say I was doing a flashcard for just the femur. I would probably put the name on the front, and we live in the digital age. You can find images everywhere on the internet, and as you look at those, you can find an image, you can cut and paste it, print it out, and put it on your card, and that'll be the front of your card. So you have a simple image with a term, and then on the back of the card, if you flip it over, that has a bulleted list, is how I would suggest to do it, of all the exact terms that you need to know. All the things you need to know for just your learning objectives are on the back of that card. So that would be a simple way to make them. It doesn't take much time, and it's a good use of your time as an active learning process. Number 8 says study with a buddy, and for this one, you want to probably find a lab partner with a similar learning style as you. If you're a very visual learner, for example, and one of your study partners in the lab is also a very visual learner, you might want to pair up and study together outside of class. It'll also help keep you very motivated in going through all the things you need to learn for the skeletal system. What you want to do is you want to say the terms aloud and quiz each other. Again, active learning, being engaged in the learning process. That's very important. And lastly, it says to take individual bones and you want to actually kind of match them up to an articulated skeleton. So, for example, if I was studying a femur and I was going over the parts of a femur, I'd want to go over to an intact skeleton like we see right here, and I would want to go over and match it up to the actual bone to figure out, what's the front and what's the back? Or what's the anterior and what's the posterior? And is this actually a left one or a right one? To figure out some of those things, you need to actually go to an articulated skeleton and match things up, like figuring out pieces to a puzzle. So that's very, very helpful. Point number 10, the last point for our presentation, is practice, practice, practice. Very, very important. As the saying goes, choosing to cram leads to failure on the exam. What you need to do is repetition, repetition, repetition. It's really important to verbally say the term multiple times. Some people, it helps to write out the term multiple times. But the key thing to remember is most students are going to underestimate the importance of practice. It takes a lot of time to go through the skeletal system, but if you do a lot of these 10 points that I just mentioned, it should help you succeed in learning the skeletal system much better for long term.
Leg bone connected from your ankle bone connected from your heel bone connected from your foot bone connected from your toe bone.
Look down here, we notice that there's a hole right there in the mandible, and that's referred to as our mental foramen. So the term in this case is just showing me where the hole is located. Another term is condyle, very, very common term. An example of this would be like what we see at the end of a long bone, such as a femur. This is the longest long bone in your body. And if we look at the end of it, just like we can see also in the slide, we have two curved surfaces like this. When I have two curved surfaces that form a joint or an articulation, they're referred to as a condyle. So foramen, condyle, two very, very common terms. They come up in many parts of the skeletal system, not just with the bones I just showed you here, but many others. And if you know those first, least amount of structures on it that you need to know, they're very minimal compared to other things. So because these are easier long bones, you may want to start there first. That gives you some momentum and carries you over to learning the more complicated things. What's the most difficult thing? The most difficult thing you're going to have to conquer is the skull. The skull has numerous bones and sutures and different processes and projections on it, and it takes a long time to learn the skull. So since this is the most difficult, you may want to wait a little bit until you start to attack that one. So if you like to build a little momentum in your studying, you'd want to go for long bones first and then gradually work your way up to the skull. Third point, get organized. First of all, you want to put all your materials in a 3-ring binder like is shown in this slide. So you may have printouts that have your learning objectives.
Your toe bone connected to your foot bone connected to your heel bone.
Hi, my name is Paul Krieger, Professor of Biology at Grand Rapids Community College, and I'd like to do a presentation today to share with you 10 tips for studying the skeletal system. Here's the outline. Point 1. Learn the bone markings. Point number 2, be sure to set up a study schedule. Number 3, get very organized. Number 4, use analogies and mnemonics as appropriate. Number 5, don't blindly memorize terms. Number 6 is visualize how bones function. Number 7, examine patterns. Number 8, study with a buddy. Number 9 is make your own flashcards. And number 10 is, and most importantly, practice, practice, practice. So let's elaborate on each of these points a little bit. First of all, learn the bone markings. What are we really referring to? If you actually look at any textbook, they're going to have a set of terms that apply to all parts of the skeletal system. And these are found again in pretty much any textbook. You'll see a table, and they'll typically be called bone markings. And let me give an example of one of the common terms that you would see. One of them is called a foramen. And a foramen simply refers to a hole through which a blood vessel or a nerve passes. In this slide, what we're seeing is a picture of the mandible, or your lower jaw, and that's just like what we see here. And if we look, it'll help you understand all the different parts of the skeletal system. So very important to do this as one of the first methods of attack in your study plan. Number 2, set up a study schedule. Chunking, what is it? When you first come upon the skeletal system, you're overwhelmed with the amount of information that you have. It's just too much. So like any huge task, what you need to do is break it up into tiny pieces, called chunking. So we take our huge task and we break it up into little tiny pieces, and it makes everything a lot easier. So what you need to do is study a little bit every day, each and every day. The long bones tend to be the easiest thing to do. So for example, I mentioned a femur earlier, the longest long bone. This tends to have some of the